So how do I find that missing A and that missing B? What is it that I should put as my A and my B that would be equal to the fraction on the left? That's what we're asking, right? Do we just randomly pick numbers and hope you hit the right one, like a kind of a lotto kind of thing? No, we're mathematicians here. Well, I'm not a mathematician. I already said that. But we're logical thinking people with math skills. We're going to put some of those skills to work right now. What we know is if we add these two together, it's going to be the same as that side. So why don't we go through the process of adding them together? One of the things you're going to notice, and it will be the same thing on the test if you get this question, is that this denominator here kind of looks a lot like that one, except this is a product. But we do know that if we're adding these two together, that we normally look for the common denominator, which is normally just the product of those two. So what I'm going to do is I'm going to go ahead and find the common denominator of these two, and then see if we can combine them using that common denominator. So that common denominator would, of course, be the x plus 1. Okay, let me make this a little bit more comfortable for myself here. So that common denominator would be the x plus 1, 3x plus 2. That's what the common denominator would be for adding those two together, which is a lot like this denominator here. So then we have to ask, what do I multiply this x plus 1 by to get this denominator here? Because I have to multiply the top by the same thing, right? Yes, Rosie. Pardon me? Multiply it by the 3x plus 2, absolutely. So it's going to be A times the 3x plus 2 plus, because it's a plus. What do I multiply the 3x plus 2 by that gives me this denominator, x plus 1 times 3x plus 2 times the x plus 1. So it's going to be B times the x plus 1. Thank you, Abel. So what I'm going to do now is I'm just going to do what we normally do. I'm going to expand that or distribute it. And I'm going to distribute this as well. So the top of this becomes 3ax plus 2a plus bx plus b. Can I sort of get a sense of whether people accept what I just wrote down? Krisha, does that make sense? I'm just expanding it, right? I'm just taking the a on the outside and multiplying by what's inside. So a times 3x or 3ax, 2 times a, b times x, and b times 1 is b. Okay? Wanya, so far so good? All right. Put that over the same denominator of x plus 1, 3x plus 2. Now, here's what I'm going to say to you. If these two things are equal, if the left-hand side is equal to the right-hand side, right? And if the denominators are the same, which they are, because look at it, the denominator on the left here, let me point to it so it will come up in the video. This denominator here is x plus 1 over 3x plus 2. And then when we multiply out the other side, it works out to be x plus 1 into 3x plus 2, same denominator. What that means is that the left-hand side of the numerators must also be equal. So here's what this means. It means that the 2x minus 1 must be equal to the 3ax plus the 2a plus the bx plus the b. I hope you accept that, right? If the left-hand side had a denominator which was 3x plus 1, 3x plus 2, and when we add the right-hand side, we have the same denominator of x plus 1, 3x plus 2, it must mean that the two tops have to be the same as well. You can't have a denominator if the two things are equal, this side is equal to this side, right? And we're saying that the two denominators are the same, then the two numerators must be the same too, if they're equal. Let me see if that makes sense to Ashton. Ashton, does that make sense? Okay. So, If they're equal, if what's on the left, if this 2x minus 1 is equal to what's on the right, let's see if we can do what's called equate the coefficients. So we equate the coefficient and the constant. Let's write that down. Equate the coefficient and constant. What do I mean by that? Well, let's talk about the x's first. There's an x here and there's an x here. Let's factor out the x out of those two terms. So let me circle the ones that I'm talking about here. Yep. They are. And that's the reason I can set them equal to each other, because the two denominators are the same. And that's why I'm saying it wrong. The two denominators are both the same. X plus 1, 3x plus 2. So it means that the two numerators also have to be the same. Okay? All right. So let me go ahead and circle the two x terms. I want red. There's this term and there's that term. Those are two x terms. So if I factor out x out of both of those terms, can somebody tell me what's going to be inside the bracket? And if I factor out that x, go ahead, please. What else? Absolutely. But I'm still left with the plus 2a and the plus b. So here's what I mean by equate the coefficients and the constant. Remember, the 2x plus 1, 2x minus 1 is still here. 2x minus 1 is still over here on this side. And this side is still x times this thing plus that thing. You know what this means? If I'm equating the coefficients, it means that the coefficient on the left-hand side in front of the x is 2. The coefficient on the right side in front of the x, well, it's really behind the x, but it's still beside the x, is 3a plus b. You know what that suggests? That 2 is equal to 3a plus b. That's what it suggests. Right? This coefficient here must be the same as this coefficient here. The coefficient here in front of the x is 2. The coefficient here is behind the x, but it could have been put in front of the x. Is also 3a plus b. So the two things have to be equal. Yes? Sure. Okay. I'm going to throw a new page in here. And I'm glad that you're asking. I appreciate that about Aria in particular and everybody else who does that. If I said that 5x plus 9 is equal to ax plus c, I just made that up. Okay? If I'm saying that those two sides are equal, right? This thing here is equal to that thing there. It means that a must be equal to 5. It means that 9 must be equal to c. That's what it means. If the things are equal, if an equal sign means that those two things are equivalent, they're the same. So it must mean that the 5 and the a must be the same and the 9 and the c must be the same. Does that make sense, Hashim? Good. So I'm saying the same thing on the previous page. We factored out that x, and you did that for us, and found out that x being multiplied by this plus these two things on the end is the same as the 2x minus 1. So 3a plus b must be the same as the 2 on this side. What else, what other equation can we come up with based on what we're looking at here right now? Go ahead, please, Che. Correct. That's exactly correct. Does that make sense, though? I want to make sure that that makes sense to everybody. What do you say to that? Okay? All right, Sahil says yes. How about Angeli? Does that make sense? Okay, good. So what does that leave us then? We have two equations, one that says 3a plus b is equal to 2, and what's that one that says minus 1 is equal to 2a plus b. What am I supposed to do with that? How does that help us out? Does that bring us any closer to a and b? Of course it does. How? Tell me how. Tell me how. Manahill, how? Because what you're talking about there, Manahill is saying that we can isolate one of the variables is substitution. It's one of the ways you solve a linear system. You could also use elimination, because what you have here is two variables with two equations. You learn this in grade 10. All right, I'm going to take the Manahill approach. I'm going to use substitution. Right? We could use elimination, but we could have, but we're going to use substitution. So isolate one of the variables. Go ahead, please, Abel. From the first equation, right? Or from the second one, doesn't matter. So I'm going to go ahead and isolate the b from the first equation and say that b is equal to 2 minus 3a. That statement make sense? Akifa, how about you? Does that, what I just wrote, make sense? Right? I took the 3a from the left-hand side, so it's 2 minus 3a, and b is now on its own. So where do I go with that, Krisha? What do I do with that information again? Now, I said substitution, so what do I do now? Say it again, sorry. Okay, so wherever I see b, I can put this thing here, right? Okay. Thank you, Krisha. So you're saying, let me see if I understand you now. So minus 1 is equal to 2a plus 2 minus 3b is what it sounds like you're saying. Rubbish. Rubbish, rubbish, rubbish. Minus 3a. Yes. Absolute nonsense. Thank you. I didn't do that on purpose to see if you're paying attention. I just made a mistake. Okay. So now we have to solve for a. That sounds simple enough. I'm going to bring that 2 on the other side as a minus 2. So I'm going to say minus 3. And that's 2 minus 3a, which is minus a. So it looks like a is equal to 3. So it looks like to me. So if a is 3, how can we use that fact to get what our b is? Go ahead, please, Sachir. Not Sachir, sorry. Shreyash. We have an equation that says b is equal to something right here. So we can go back to the left-hand side and say b is equal to 2 minus 3 times 3. So that's equal to 2 minus 9, which is minus 7. So if what we did is right, which I believe it is, and we can check this, then the answer to the question is, a is 3, b is minus 7. That's what we're saying the answer is. But how do we check this? By putting it back into what we said it was equal to. I'll show you what I mean by that. Go back to the original. It said that this over x plus 1 plus this over 3x plus 2 is equal to this. Well, let's see if we put an a value of 3 here and a b value of minus 7 here. If we simplify it, will it come back to this left-hand side? To me, when I'm doing a test, when I was doing tests, when I'm sitting where you're sitting, after the first time I blew a test, which I know I've done, that has happened, I started checking my answers. I started saying, okay, there must be a way to see my answer is right. I'm going to do that right now. I'm going to put the a and the b here, work it out, see if it works out to be this. So, this is the check. The a value we said was 3 over x plus 1 plus minus 7 over 3x plus 2 we're going to do the math on that now. So the common denominator is still x plus 1, 3x plus 2 But then I'm going to do what we did before, except I now know what A and B are. What I multiply x plus 1 by, that gives me that. It's going to be 3x plus 2. So it's 3 times 3x plus 2. And then I'm going to ask what I multiply this by to get this is going to be x plus 1. So it's really minus, because plus minus means minus, minus 7 times x plus 1. Okay? Let's continue the math here. That's going to be 9x plus 4 minus 7x minus 7 over the same x plus 1. Yes. 3 times 2 is not 4? No? Yeah, I don't think it is it? No. Yeah, thanks. Good call. Never used to be 4, it's not 4 now. Thank you. 3x, 9x plus 6. We're going to figure out in a little while that was going to be wrong. Anyway, x plus 2, x plus 1 times 3x plus 2. Thank you very much. Simplifying that, we're going to get 9x minus 7x is 2x. 6 minus 7 is minus 1 over x plus 1, 3x plus 2. Guess what? We just proved that our answer is right. Because if I go back to the start, there's my 2x plus 1 right there, using the numbers that we got as our A and our B. To me, that's what I need to do every time I get an answer that I'm not sure about. I want to check it. I want to make sure it's right. Okay? So there you go. That's the end of that question. Do I need to go over any part of that? Be like Aria. And there's other people, not just Aria. There are people who will stop me and say, I'm not so sure about that. So cheer, what's wrong?
Thing I didn't understand was like this part. How you said that 2 is equal to 3.
Okay, good. So let's talk about that. Thank you for bringing that up, Sachir. So what we're saying is this. Let's go back to the start. These two things are equal to each other, right? The two sides are equal to each other. It's important that we understand what equal means. Whatever is on the left is equivalent to what's on the right. If we combine these two, it's going to look like this, right? Makes sense? If you're adding fractions together, common denominator, so on and so forth. So now we have, when we expand the a into this, we have 3ax plus 2a plus bx plus b. So what I said is, okay, this whole thing at the top here, all of this at the top, must be the same as all of this at the top of this one because we said the two sides are equal. But we need to figure out how we can make them equal. To make them equal, I said, well, let's factor out the x out of the two x terms, the ones I've circled in red. Okay? And what I heard was that if I factor that x out, I'd end up with x into 3a plus b. Then I'd have the constant, which is a 2a plus b. So it must mean then that if I'm going to equate this thing, so I'm going to put a circle around something here. This part here must be equivalent to the 2 over here. They have to be because they're in front of the x. They're beside the x, right? So this is like the coefficient of the x. I mean, it's coefficient, but it's behind the x. So what? When you multiply two things, the order doesn't matter. Okay? So whatever I'm multiplying by x here must be equivalent to what I had multiplying by x over here. That's why this must be equal to 2. And I also asked, and somebody over here answered it. I forget who it was. I think it might have been, I don't remember who it was. Somebody said that also means that the minus 1 must be the same as the 2a plus b. So we set them equal to each other. And that's what we just did. Okay? All right. And then the rest of it was using the linear system that Manahill suggests we use the substitution method. We even checked it and we got the answer back. Okay. Last question, which is not this. It's this. All right, I know someone's going to ask you to make it bigger, so let me try doing that right now. Find the ratio of the volume to the surface area of the rectangular prism and simplify it. So I'm going to remind you of the formulas, and I'll give you the formula. If I give this question to you on the assignment, I'll give you the formulas if you don't remember them. I know the one for volume you're going to remember because everybody knows that volume is length times width times height. But I'll write it down anyway. For a rectangular prism, V is length, width times width times height. Surface, surface area is a little bit more, a lot more work actually. Does anybody remember how to find the surface area of a rectangular prism? Before I write the formula down, does anybody remember? Nobody? All right. So what's happening is that you're going to take each of these faces of the rectangular prism and find the area. So you're going to multiply the length times the height. Then you're going to double it because there are two of them. There's a front and a back. You're going to multiply so for the top now, you're going to multiply the length times the width. Then you're going to double that as well. And then you're going to multiply there's another face, the side face. Then you're going to multiply the length times the height and then double that. So there are three things we have to multiply and each one has to be doubled. Okay? The short method to say that is this, but I'll give you the formula. It's 2 times, actually, let me move this whole thing over, give myself some more room. No, that's not what I want to do. So it's 2 times L times W plus L times H plus H times W. So we have to take each of these products. So every possible way of combining the dimensions has to be multiplied, and then we have to double it. Okay? Because every single one of these has two faces. There's a right face and there's a left face. There's a front and there's a back. There's a top and there's a bottom. Okay? So that's the formula. You should remember that from grade 9, even if you don't remember all the pieces of it, but you've seen that before. Let's do the easy one first. Before I do the easy one, I'm noticing that all of these sides can be factored. Every single one of these sides can be factored. Well, two of them can be factored. The 4x plus 8, can anybody help me to factor that? The 4x plus 8. Go ahead, Suchir. Okay, so you're left with what? 4 into x plus 2, good. Can the left side, the height that is, be factored as well? Go ahead, Ashton. Take out the 2, and what are you left with? Good. So one side is 2 times x plus 2. One side is 4 times x plus 2. One is just x plus 2. Yes? Work, just, I tell you what. Hang on for the ride and see what happens next. And know that if I give you this question, it's going to be factorable just like that. Okay? So, let's get to volume, the easy one. The volume is going to be equal to 2 times x plus 2 multiplied by 4 times x plus 2 multiplied by x plus 2. What does that look like to you? What do you think that's going to work out to be? Right? I see some common bases there. So it sounds like we can put those x plus 2's together and say that we're raising that x plus 2 to the power of what? Yes, 3. And then the 4 and the 2 will give us 8. Does that make sense? I have the x plus 2 times the x plus 2 times the x plus 2 That's really x plus 2 to the power of 3, just like Ashton just said. The 4 times 2 gives us 8. So we have something for volume. Volume is covered. Now, the one that's more tedious is the surface area. But let's just see if we can deal with this. The SA is equal to 2 times, okay, length times width. I'm going to use this as the length, and I'm going to use this as the width, right? So it's going to be the 4 into the x plus 2 times the x plus 2, right? So I'm multiplying this side by that side. We'll deal with that a little later on. Plus, let's combine now. I took these two together. Let's take these two together now, right? So plus 4 x plus 2 times 2 x plus 2. Whoa, running out of room here. Yeah, I didn't do a good job with this. Let me see if I can move this over. Okay. Plus, which one haven't I done yet? Which one haven't I multiplied yet? I've taken this with this. I've taken that with that, but I've left one out, which is the one I haven't done yet. Yes, Aaron? The height and the width. So in other words, the x plus 2 and the 2x plus 4. So let's do that. So plus 2x plus 2 times x plus 2. Now you might be thinking, why don't I, in fact, you know what I'm going to do? I'm going to put a square bracket on this part right here. Oh, sorry. Another square bracket over here. Okay. Now let's see if we can break this down a little bit more. These x plus 2's, when I multiply these x plus 2's together, there are two of them at a time, right? Isn't that true? Uh, Abdullah, we're multiplying two at a time, right? So I should get x plus 2 to the power of what? X plus 2 to the power of 2. Okay. So that should be equal to 2. Let me go back to the square bracket again. 4x plus 2 squared. This is just a dot here. Plus 4 times 2 is 8. X plus 2 squared plus 2 x plus 2 squared. All right, again, I'm not doing a good job with space here. Let me try to get everything moved over there. Then we close that bracket. Oh, no, I don't want to lose anybody, so let me just go over this again. When I multiply these two together, I'll use this actually. When I multiply these two together, I get 4x plus 2 squared. When I multiply these two together, I get 8x plus 2 squared. When I multiply these two together, I get 2x plus 2 squared. Yes? It says something you can't even read properly. Let me erase that and put it back. Okay. So 2x plus 2 squared, and then I'm going to close the bracket. So this is coming from multiplying these two together, the 2x plus 2 squares, okay? I have a 4x plus 2 squared here, I have an 8x plus 2 squared here, and then I have a 2x plus 2 squared here. That means they're like terms. It's like saying 4x and 5x and 9x. So how many x plus 2 squareds do I actually have then, is the question. When I add all those x plus 2 squareds up, what do I actually have? How many x plus 2 squares? Yes, go ahead. 7. 4 and 8. Yeah, you're adding all of them. So this is 4 of them here, 8 of them here, and 2 of them here. Isn't that what you should be doing? This is an x plus 2 squared, and there's 4 of those. There's 8 of them here, and there's 2 more of them over there. We're just putting them all together. 14. There you go. So there's 14 of these x plus 2 squareds. So what that means, if I multiply now the 2 and the 14, is I have 28 x plus 2 squareds is what I really have. So this is where we are. This is our surface area. So our volume, we said, if you go back, our volume was 8x plus 2 cubed. So volume to surface area is 8x plus 2 cubed to 28x plus 2 squared. So that's the ratio that we're trying to simplify, right? It's correct as it is, but it's not simplified, right? This is the ratio of the volume, which is this, to the surface area, which is this. Can we reduce this down? Absolutely. If you have a ratio, right, then it means that you can divide the both sides of the ratio by the same thing. What can I divide the two sides of this ratio by? Think of it like a fraction. A ratio is just like a fraction, like a numerator and a denominator. Can I divide both sides of this ratio by anything? There's an 8 here and a 28. Let's start with that. Yes. I can divide that by 4. What else can I divide both sides of this ratio by? Yes, Che. X plus 2 squared is also something I can divide them both by, which I believe is what Manhill was going to say as well. Now, if I do that, what am I going to be left with on the left side of the ratio? What am I left with on the right side of the ratio? Because that would be your simplified ratio. Okay, go ahead. Not just 2, and right, and on the left side, it would just be 7. That's your ratio right there. That's your ratio of volume to surface area, 2x plus 2 to 7. You can put it as a fraction if you like. A ratio can be a fraction, right? Just so you know. But that's your answer. Yes. You mean like multiply it out? It's not really simplifying it. I'd call that distributing it. And it's not necessary. It doesn't make your answer any more simplified, really. It's just another way to present it. So I leave it as it is. Right? And it's a good thing to keep it factored, because just in case there's some other common factor, the fact that it was factored up here made it easier for us to see that there was a common factor. So I'd leave it like that. Right? Is it okay to multiply it out? Of course. But I leave it like that.